Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at geometric series, sums for geometric sequences. Remember that a geometric sequence starts with the term a sub 1 and gets multiplied by a common ratio r to find successive terms. The sum of the first n terms of one of these sequences is given by the formula on the screen. S sub n equals a sub 1 times 1 minus the common ratio raised to the nth power, all divided by 1 minus the common ratio. And that holds true as long as the common ratio isn't 1. The first problem, a person receives a gift on January 1st of $10. On the first day of each subsequent month, the amount of the person's gift doubles. Find the general term for this geometric sequence, and then determine how much the person will receive from January 1st through September 1st. So first thing we know is that a sub 1 is $10 and the common ratio is 2. We double it each month. The general term a sub n is equal to a sub 1 times r to the n minus 1 power. We don't really need that for this sum, by the way, but I'm just asking you to find that first. So here, sorry about that. Here, a sub 9 would be a sub 1, which is 10. I'm sorry, a sub n would be 10 times r to the n minus 1 power. I'm sorry, that should be, I think losing the screen threw me there, times 2 to the n minus 1 power. All right. To find the sum of the payments made in the first 9 months, the gifts made in the first 9 months, we'll use the formula above. We're going to be looking for S sub 9 for 9 months. That's going to be a sub 1, $10, times 1 minus 2 to the 9th power, r to the n power. And that's all going to be divided by 1 minus r, which is 1 minus 2. Now, we can clean up some of this. I don't want to really worry about figuring out what 2 to the 9th is, but I would like to clean up the denominator a little bit. 1 minus 2 is negative 1. So we've got 10 times 1 minus 2 to the 9th power over negative 1. And I could divide 10 by negative 1 to get negative 10 times 1 minus 2 to the 9th power. Now I can go to the calculator. Let's try that. Negative 10 times, parentheses, 1 minus 2 raised to the 9th power. And there we have $5,110. That is the amount in total that those gifts from the first 9 months would represent. Problem 6, find S sub 8 for the geometric sequence 6, 18, 54, etc. If it's a geometric sequence, I know that A1 is 6. I want to make sure that we're multiplying by the same number each time. I could do it by dividing. 18 divided by 6 is 3. 54 divided by 18 is also 3. So the common ratio is 3. And I want to find S sub 8. So S sub 8 would equal a sub 1 times 1 minus the common ratio to the 8th power divided by 1 minus the common ratio. And that's using, again, this formula that's boxed at the top. Real quickly, notice that these sums do not depend on knowing the last term like we had with the arithmetic series. It only depends on the first term and the common ratio. That's it. Substituting in, A1 is 6 times 1 minus 3 to the 8th power over 1 minus 3. Now, we could type it like this. Let me show you what that would look like. Fraction 6 times parentheses 1 minus 3 to the 8th power, and in the denominator 1 minus 3. And there's our sum, 19,680. But we could also simplify some things, and let me show you what that looks like. So first, 19,680, that is the result. I could make this denominator of 1 minus 3, that is negative 2. And I could divide negative 2 into negative 6, that goes negative 3 times. So I could have just multiplied negative 3 by that expression. Negative 3 times 1 minus 3 to the 8th power, and there we have the same exact result. One more to go here. This is a geometric sequence that we're taking the sum of, but it's in hiding. Notice it's 3 times 6 to the I power. That 6 that we're multiplying by, oops, there we go. That 6 that we're multiplying by, that is the common ratio. It's 3 times 6 to the first, 3 times 6 to the second, 3 times 6 to the third. That 6 that's being raised to that power, that is the common ratio. What else do we need? Well, we know that n here is 5. And I do need to know what a sub 1 is. And that's going to be 3 times 6 to the first power, which is 18. So s sub 5 equals a sub 1 times 1 minus r to the 5th power over 1 minus r. That is 18 times 1 minus 6 to the 5th power over 1 minus 6. Here, 1 minus 6 is negative 5, but notice that I can't divide that into 18 evenly. So I'm going to type it using the original form. Fraction 18 times parentheses 1 minus 6 to the 5th power over 1 minus 6. And again, I could also have put negative 5 down there. This time the sum is 27,990. And that's it for this video. We'll be back with one last video for geometric series in the next video.